So these are answers to the questions in the worksheet. So verify your answers. So here you have to explain 3 reasons why melting point of calcium is higher than that of potassium. These are the 3 reasons, and also mention that all these 3 reasons lead to calcium having stronger electrostatic attraction than potassium. And as you are giving your answer, compare calcium to potassium. You see, every time I'm comparing with potassium. Ionic radius values, you will get it in the data booklet. So you can pause the video and take down the answer. And here you have to list in order of increasing melting point. So you're going to go from bigger to smaller. This is answers to question on page 7. And these are answers to question on page 8. And for metallic structures are insoluble in water. So if you take, for example, copper is a metallic structure, insoluble in water, very high melting point, electrical conduction in both states, molten and solid. For this question, so you have to explain why metals are malleable, including a label diagram. So you have the label diagram where I'm showing a force applied which pushes the layer away. And you have the cations labeled and the sea of delocalized electrons shown. And you see that metallic bonding is non-directional, which means that whenever a force is applied, the delocalized electrons allow layers to slide past each other without breaking the electrostatic attractions. You have then to explain the trend in electrical conductivity of sodium, magnesium, and aluminium. So as the number of delocalized electrons increases, electrical conductivity is going to increase. So number of electrons contributed by each atom increases. And this results in greater charge density, hence greater electrical conduction. Then you have to explain why electrical conductivity of metals decreases with increasing temperature. At high temperatures, cations vibrate more, and the cations, as they are vibrating here, they get in the way of the electrons that are moving. So for the metal to conduct electricity, the electron must go from this point to this point. But when the cations start vibrating, the cation is going to hit with the electrons and it disturbs the flow, it interrupts the flow of electrons. This increases resistance and decreases conduction. This part, this is HL. So you have to suggest why electrical conductivity in copper is higher than that in other elements. Copper is a transition metal, so it will not only lose its valence electrons, it will also lose delocalized d electrons. So it gives greater conduction. Last question. Identify the structure for each element in period 3. So sodium, magnesium, aluminium, these are metallic. Silicon is covalent network, so giant covalent structure. And phosphorus, sulfur, and chlorine and argon, I missed argon here, these have molecular covalent structures. Phosphorus, sulfur, chlorine have molecular covalent structures, while argon here is just existing in its elemental state, uncombined. And you have to plot a graph. You can try to plot the graph on, you can use graph paper or you can use sheets. So here you have boiling points on the y-axis and atomic number on the x-axis. and you can look for the atomic numbers for each of these elements, and then you plot the graph based on the data that is provided to you. Last question, you have to explain the trend in boiling point and then describe and explain the trend in electrical conduction. I did this question in a table. So sodium, magnesium, aluminium, they all have metallic bonding, so boiling point increases as metallic bonding strength increases. So here you have greater number of delocalized electron. So you also have smallest ionic radius. So here boiling point is highest compared to sodium. Silicon has highest boiling point out of all of them because of the strong covalent bonds in the network. Phosphorus, sulfur, chlorine, and argon, all of them, they have very low boiling point because all of them, they have London dispersion forces, which are weak forces. Phosphorus and sulfur, they will have higher boiling point, with sulfur having the highest boiling point out of these four, because sulfur has a large molecular mass. So S8 exists like this as a crown structure. P4 exists like this. So the greater number of electrons, greater molecular mass leads to stronger London dispersion forces. And argon will have the lowest boiling point due to the weak London dispersion forces between the atoms of argon. Conductivity, all of them, they will be very good conductors of electricity, with aluminium being the best out of these three. Silicon is a semiconductor. It has low conductivity at low temperatures, and it lacks mobile charges. You can ignore the information about low temperatures, so just know that it's a semiconductor. And for these four, they are poor electrical conductors. There's no mobile charges. So you can pause the video and then note down the answers for any of these questions. With this, we finish with metallic bonding.